Hey everyone, Sankalp Kaushik here. I hope you all are well and I'm delighted to have you. This video is a part of the final assignment of Tall Building Design course from Skyfi Labs. In this video, we will be analyzing and designing a G+23 story building using ETAP software. So here is the problem. We have to design and analyze a G+23 building. The lateral section of the building is different for different sets of stories. The dead load is same for all the story of building, that is 2 kN per meter square. But the live loads are different for each of the similar sets of floor. For story 1 to 8, the live load is 5 kN per meter square. For story 9 to 14, the live load is 4.5 kN per meter square. For story 15 to 19, the live load is 4 kN per meter square. And for story 20 to 23, the live load is 3.5 kN per meter square. Also, three sections of the beams and columns are given, each of which are having M40 grade of concrete and HYSD 500 for longitudinal bars and mile 250 for tie bars. The slabs are of 150 mm thickness and having M40 grade of concrete. We will be using auto truck loading having a load of 0.2 kN per meter. For the wind load, we will be considering the parameters for a building to be constructed in a Bangalore city. Now let's open the ETAP software. Select New Model from the File menu. And select the options as display. Make sure the display unit is metric SI, region for default materials as India, steel section database as Indian, steel design code as IS 800 2007, and concrete design code as IS 456 2000. Click on OK. In the uniform grid option, set the number of grid lines as 4 in both X and Y directions, and set the spacing values to 6 meter each in X and Y direction. Then in the simple story data option, set the number of stories to 23 as it is a G+23 story building. Both the typical and bottom story height to 3 meter. Now we need to define the set of similar stories data, so click on Edit Story Data. We can see that story 23 is selected as the master story and all the stories are similar to story 23. So we have to create different master stories to divide the stories into smaller sets of similar stories. Story 1 to 8 are similar. So go to any one of the stories, let's say for story 8, and change it to the master story. And change all the remaining stories to similar as story 8. Now for the next set of similar stories, that is story 9 to 14. So let's take story 14 as master story. And set stories 9 to 13 as similar stories to 14. Again, for third set of similar stories, 15 to 19, select story 19 as master story. And the remaining stories to a similar to 19 story 19. The remaining stories from story 20 to 22 are already similar to story 23. Now click on OK. Now select the grid only option and click on OK. The 3D grid has been created. Now we have to define the material properties. So go to define, select material properties option, click on add new material, select the region as India, material type as concrete, standard as Indian, and grade as M40. Click on OK. Click on OK again. Now again follow the similar steps and this time change the material type to rebar. And grade as HYSD grade 500. Click on OK. Click on OK again. Similarly one more time. This time grade is mild 250. Click on OK. Click on OK. Click on OK again to exit. Now we will define the section properties. Go to the define menu. Select frame sections from the sections property. Click on add new property and select the concrete rectangular option. Enter a name for the column section of 500 mm by 500 mm. Change the material to M40. Change the dimensions to 500 each. Click on modify show rebar. Here no change is required as it is already selected as column design type. Change the longitudinal bar material to HYSD 500 and confinement bars, that is tie bars, to mild 250. Now click on OK. Click on OK again. Now we will need to define two more columns which are having similar properties but only having difference being the section dimensions. So instead of adding new property each time, click on the defined column and select add copy of property. Here change the section name of column 550 by 550 and change the dimensions to 550 mm in both depth and width option. Click on OK. Click on. Now the section of 550 by 550 dimension has been defined. Similarly select the column one more time and click on add copy of property to add another column of 600 mm by 600 mm. Change the property name. Change the required dimensions and click on OK. Now that the three column sections are defined, we will need to define a fourth property which is having a combination of all the three defined column sections. Click on add new property. Under the spatial option, click on auto select option. Then give the name as auto select column. Change the design type to concrete. Then select the three defined column sections. Click on add. Click on OK. The three column sections have been added to the auto select list. The use of the auto select option is that software will assign the frame dimensions as per the load requirements. We do not have to assign it individually. Now adding the three beam sections similarly. Click on add new property. Choose rectangular section. Change the name of beam section of 500 mm by 300 mm. Change the material to M40. Change the dimensions. Click on modify show rebar. Change the design type to beam this time and select the longitudinal rebar material to HYSD 500 and confinement bars to mild 250. Set the clear cover for both top and bottom bars as 25 mm and then click on OK. Now add another beam, section 500 mm by 550 mm by 350 mm. Click on add copy of property. Give the name. Change the dimensions. Click on OK. Once again, click on add copy of property to add a beam of dimension 600 mm by 400 mm. Change the dimensions. Click on OK. Now that the three beam sections are defined, we will add the auto select list property for the beams. Click on add new property and select the auto select list option from the spatial. Give a property name for the auto select list. Change the design type to concrete. Then select the three defined beam sections. Click on add. Click on OK. Click on OK again. To define the slab section, select slab sections from the define menu. Add new property. Enter a name for the slab property and change the slab material to M40. This is a slab of 150 mm thickness and change the slab material to M40 and thickness to 150. Click on OK. Click on OK again. Now we have defined all the required properties and sections. Now we will be drawing the elements in the plan view. Go to story 1 by using the arrow keys. Now select the quick draw column icons from the shortcut bar. Change the column property to auto select column. Select the similar story options from the bottom right corner. Now select the whole grid area to place the columns at the grid intersections. Now select the quick draw beam options. Change the property to the auto select list for beam. Now select the whole area to draw beams over the grid lines. Select the quick draw slab option. Change the property to the defined property of slab. And select the area to draw slab on it. The beams, columns and slabs have been drawn in the first set of similar stories. Using the arrow keys, go to the story 9. So that we can repeat this procedure again for another set of similar stories. Now click on quick draw columns. See that the auto select is list property is selected. And draw the columns over the desired area as shown. Similarly, select quick draw beams option. Check that the auto select beam option is selected. Now select the desired area as shown. Now select quick draw slabs. Make sure the correct property is assigned. Now draw the slabs of the desired property over the area. Now go to story 15 for another set of similar stories. To draw the column, beams and slabs in the similar manner as we have done previous. For last set of stories, go to story 20 and perform the same practice. Press escape to exit the draw mode. Now we will apply the loads on slabs and claddings. Go to story 1 since the dead load is same in all the stories. Select all stories option as the dead load is same for all the stories. Then select all the shell one by one. After all the shells are selected, go to the assign menu, choose shell loads and click on uniform. Set the load pattern name to dead and enter the load value of 2 kN per meter square. Click on apply and then click on OK to exit. We will apply the live loads which are different for different sets of stories. So select similar stories and select the slabs again one by one. This time only the slabs of the stories similar to story 1, that is stories 1 to 8 are selected. Go to the assign menu, then shell loads, then on uniform. Change the load pattern name to live and change the value of the live load to 5 kN per meter square. Click on apply, then click on OK. Now go to any of the stories from 9 to 14. Choose similar stories and select all the shells one by one. Then go to the assign menu, choose shell loads and then uniform. Change the live load value to 4.5 and click on apply and then click on OK. Similarly, go to any of the stories from 15 to 19. Select all the shell loads, select all the shells one by one and make sure the similar stories option is selected. Select the live load as 3.5 kilonewton per meter square from assign menu, then shell loads, and then from uniform. Change it to, the live load here is 4 kilonewton meter per square. Change the value to 4 kilonewton per meter square, then click on apply and then click on OK. For the last set of stories, go to any story between 20 to 23. Select the shells, go to assign menu, then shell loads, then uniform, and change the value to 3.5 kilonewton per meter square. Click on apply, then click on OK. The dead loads and live loads have been applied to all the stories of the building. Now we will apply the cladding loads. So go to story 1. Now choose the similar stories option as it is already been selected and carefully select the exterior beams. Go to the assign menu, choose frame loads and then distributed. Enter the uniform load value of 0.2 kilonewton per meter square and then click on apply and click on OK. Now go to one of the stories from 9 to 14. Select the exterior beams. Once the selection is done, assign the uniform load of 0.2 kilonewton per meter square from the load options under the assign menu. Click on apply and click on OK. Similarly, assign the loads for remaining sets of stories. This is the fourth and the last set of stories. Click on apply and then click on OK. Now we need to remove the cladding loads from the beams of the topmost story as there are no walls above them. So go to the last story, that is story 23. Select the one story option. If it not appears on the bottom, click on display and then click on deform sheet. select one story option. Then select the exterior beams. Go to the assign menu. Under the frame loads, choose the option delete existing load to remove the loads. Click on apply and then click on OK. Now go to the base, that is plan view, that is the base. Now select the base joints using the one story option. As one story is already selected, change them to fixed from the restraints option of the assign menu. Joints, then restraints, and click on this fixed value. Click on apply. First we have to select the whole area. Then go to assign, then joints and click on restraints. Click on fixed and then apply and then click on OK. Now go to the draw menu, select auto draw cladding. Select the use floors option and click on OK. The claddings have been drawn around each floor of the buildings. Now coming to the wind loads, first we have to define the wind load. So go to the define menu and select load pattern. Type the load name as wind. And in the auto lateral, select the load type as wind. And in the auto lateral load option, select IS 875-2015 for wind loads. Then click on add new load. The new load is added in the list. Select the newly added wind load and click on modify lateral load. Here for the wind load setting, we have to refer to the IS 875 part 3. The data which I am using is taken from the IS 875 part 3. Click on OK to store the settings of the wind load. Click on OK again. We will now assign the wind loads onto the building claddings with the plan view tab selected. Click on the elevation option. Select the elevation side A and click on OK. Select the all story option and select all the cladding shells. To identify the wind pressure coefficients, open the IS code again. From the IS code, the coefficients are 0.8, minus 0.25, minus 0.8 and minus 0.8 for sites A, B, C and D respectively as per the building plan on the IS code. Now go to the assign shell loads. Click on wind pressure coefficient. Change the coefficient value to plus 0.8 and select the windward option. Then click on apply and click on OK to exit. Now again select the elevation option and select the section B. Click on OK. The remaining claddings in the windward side of the building, which will be subjected to the wind loads, are visible. Using all stories option, select all the cells. Apply the same wind pressure coefficient of 0.8 in the windward direction to the cells. Click on apply. Click on OK. These cells have not been assigned, so select these shells once again and then click on assign shell loads with pressure coefficient and apply it to as well. Click on OK. Now go to the plan view option and select story 1. Click on OK. Now the opposite side of the windward direction, that is the side B from the IS code, correspond to section C and D for different stories. First go to the elevation view. Select section D and click on OK. Select all the shells with the all stories option. The corresponding wind pressure coefficient for this side is minus 0.25. Change the value to minus 0.25. Click on apply and then click on OK. This time we have to remove this because it is on the leeward side. So again select all the shells. Go to assign shell loads, wind pressure coefficient, and delete existing load, as we have applied the load from the windward side, but the load should be on the leeward side. So first we have to remove the existing loads. Click on apply and then click on OK. Now select once again all the shells. Go to the assign menu, shell loads, then wind pressure coefficient. Enter the coefficient value as minus 0.25 and select the leeward side. Click on apply and click on OK. The wind load is applied. Now go to the elevation view option and select section C. The wind load in this section will also be minus 0.25. So select the visible shells. And apply the wind pressure coefficient of minus 0.25 in a similar manner. The wind loads on side A and B as per the IS code has been applied. Now we will apply the wind loads on other two sides, which have the same wind pressure coefficient of minus 0.8. In the elevation option, select section 1 and click on OK. Select all the shells using all the stories option. Since the coefficients are same in other sections also, we can select them together using the arrow keys. Navigate to the elevation section 2 and 3 and 4 and select all the shells in each section. Once all the shells are selected, go to the Assign menu, click on Wind Pressure Coefficient. Here, change the coefficient value to minus 0.8 and select the leeward side and click on Apply and click on OK. The wind load in the elevation section 1, 2, 3 and 4 have been applied. Select Story 1 and click on OK. The loads are applied in all the shells in each side. All the properties, sections and loads have been applied to the building model. Now we will run the analysis and design the building. Select the 3D View tab and select the Use Extruded View from the Frame Objects option from the toolbar. Use Extruded View for Frame Objects. The frame extruded view on the building is shown. Go to the Analyze menu, select Run Analysis, save the file, it will take some time to run analysis on it. Once the analysis is completed, we can check for the displacement values. Now, we run design on the building. In the design menu, select concrete frame design and select Start Design Check. Wait for some time as the software runs design on the building. Once the design is complete, we get a pop-up that analysis and design section differ for a 705 concrete frames. This means that initially the software uses the smallest concrete frames from the auto select list, which is the 500 by 500 mm section for columns and 500 by 300 mm for beams. As 705 number of frames have failed the design check, and thus the software asks for permission to reiterate analysis and design. In reiterate, the 705 failed members will be changed to the next higher section, that is 550 by 550 mm for columns and 550 by 350 mm for beams. Click on yes and the software will increase the dimensions of the failed frame sections from the auto select list and will automatically run analysis and design. It may take some time. This time, after the completion of running design, there may occur a second pop-out regarding failure of one concrete frames. We have to reiterate again and again till the notification stops. Now, there is no notification regarding failure of any members, and the 3D view displays the longitudinal reinforcement. Thus, the design of the building is completed. We can zoom it into the 3D model and check reinforcement value in each member. Right click on any member to check the design information. The project report and summary report is also generated, which we can access from the left menu as shown. Thus, we have successfully analyzed and designed the tall building using the ETAP software. Thanks for watching.